able to share my screen. Still coming in. Okay, good. Well, I wish I could see the flow, because that's actually, I love it when I can see yeah. Wow, that's cool. All right, so this is the first one. If things go well, I'll get a chance to do a couple other ones, and we'll drill down on the couple different topics. But especially when I do kind of like the first time I talk to a group of people or whatever, this is one of the presentations I always start with, because if you choose, if there's a performance issue and you choose the wrong strategy, it's going to take you a lot longer to solve it, and you may not even be able to solve it. So I like to start with this one. And you might have seen on my website, if you download it, I had another presentation just like it, but it has the Oracle Cloud in there in the middle. And really, for us, as long as we can SSH to the database, it's not going to make a whole lot of difference. All right. So this is going to be on premise, in the Oracle Cloud, in another cloud. This is all going to apply to however Oracle is actually installed. So I want to start with this. So here are some situations. All right. I'm gonna drill into these a little bit, but I just want to quickly review these, and then I'll introduce myself and all that. So the first one is, the user community says that on Friday afternoons, performance is always slow. Okay. So there's some very specific characteristics about this, and we'll talk about those in a minute. Another situation is a few users called after lunch, right? After called, and they report that their screen sometimes froze for up to a minute, and this happened right around 10:30. Okay, so that's the second one, very different than the first one. Right? And the final one here is OEM showed an unusual activity spike, and it lasted for like 40 minutes, and it disappeared, and then nobody called. And this is actually a real life one. I couldn't make this one up. It's too good. So what we're going to talk about today is, I'm hoping by the time I'm done, you'll have a really good idea of which strategy to actually use for each one of these. Okay. Not that they're all three different strategies, but I want you to be comfortable with that. So that's really the whole objective and what we're going to do today. So I'm going to do some lecturing, and I'm going to do a couple really big demos. They're going to be live. One of them's actually live. I'm going to be in, SQL Plus, so anything can happen when we actually do that. So as Elam said, my name is Craig Schallhammer, and I'm a longtime Oracle DBA, and my specialty is Oracle Performance. So I do a lot of research, and I post that in my blog. Author of a couple books that I'm really proud of, and I do a lot of speaking, teaching, and a lot of mentoring. I work really closely with Oracle DBAs all over the world, and I'm an Oracle ACE director, and I'm also involved for IUG, and I may be the track manager this year. That's 90%. I'm almost sure, but not yet. So OraPub is a company, though. I work closely with Oracle DBAs, and we are all about performance management and working with Oracle DBAs to take them to the next level, wherever they're at in their performance kind of tuning journey. And if you've ever been to the website, I have tons of downloads, tools, presentations. Some of the webinars are free and public, and the rest of them, like I do 2 a month, are just for my members, and those are for people that are actually really serious about performance tuning, specifically with Oracle. And we have a membership program, and that all my super primo content is saved, for these folks. So I won't tell anything more about that, but if you're interested, check it out on my website. Okay? If you guys ever want to contact me, if you're an OraPub member, then Slack is the way to get me. But everybody else, feel free to email me. That's how you get a hold of me. Okay, don't tweet me. LinkedIn works, but it's a hassle, right? To email on that. So just shoot me a straight email. That's going to be fine. Okay, that was like the quickest intro I've ever done. That's good, because we have a lot to cover. So and if you guys have any questions, type them in. I can't see them, so those are going to be repeated to me. All right, and I like those to kind of. Yeah, I really like, that's why I like to see the questions, because I really like an interactive, and I'm going to ask you guys questions as we go throughout this, because I have this thing I always have next to me called my typing log, and that kind of slows things down, and I ask a question and you guys answer, and we talk about it, do that. So I try and make this as less of a monologue as possible, and which can actually be done, believe it or not. So, all right, analysis options. Okay, this is from my Craig's personal experience, like 99% of all the performance situations I've come across in my career, I've been able to solve it using, essentially this is an AWR type of report, stats pack analysis, using ASH, active session history, or somebody just says, Craig, tune this SQL, okay? Now what we're gonna focus on, because I hate when people just say tune the SQL, because that limits me and I don't have a lot of information, and you'll see what I mean when we actually get into it. I feel like I'm handicapped right here. Like they say, tune this, like build this wall, Craig, but by the way, you got to put your hands behind your back. Like, what is that, So we're going to focus on time-based analysis, and I mean AWR report and then ASH. So I'm going to introduce both of these, and I'm going to demonstrate how to do an AWR analysis. And then if I get a chance to do a couple more webinars, then I'll drill into each one of these for the full hour, okay? And I have full-on classes and stuff on this stuff, so you guys are gonna get to like, I'm gonna download here. All right, so back to these situations. Okay, so I want you guys to type in, for this one, what are some of the characteristics of this situation? Not solutions, not what the problem is specifically, but just tell me about what you hear they're saying. What is unique about this? Okay, so like what is, I'll say unique about situation number one. Okay, so go ahead and type some of those in here. Okay, and this is not rocket science. Yeah, okay, excellent. It's repeatable, right? Every Friday it's slow. Okay, excellent. Predictable. Yeah. Yeah, exactly. Anything else? There's one more I'm looking for. Anything else? Okay, yep. We're not looking for specifics, but that's good. You're trying to relate this right away to a situation. Yeah, okay, so that's going to be our repeatable. Yep, it's predictable, it's repeatable. Okay, the last thing is that it's, okay, hey, DBAs, yeah, all right, yeah. Okay, that's what I was looking for. Pervasive. Okay, all right, stop typing. This is great. All right, so this is a situation where if I was at the company and I went to somebody on Friday afternoon and I would say, man, performance is really slow today. And somebody, they would look at me and they'd say, well, Craig, it's Friday afternoon. Performance is always slow. And I'd say, oh yeah, I forgot. In other words, it's an expectation and it's pervasive. Okay, this is perfect for an AWR report. Okay, this is perfect. Okay, perfect for AWR report analysis. Okay, when it's like instance wide, when we're looking at the ocean of activity. Okay, different situation. Okay. In fact, okay, this says, right, a few users called after lunch to report their screen sometimes froze for up to a minute around 10:30. So what are some of the characteristics about the second situation? Type those in and go ahead and read those off here. Everybody's quiet now. I freaked them out. And these are very similar to what you did before, but just a different situation. All right, anything coming in? All right, so, all right, okay, let me ask you this. Is this repeatable? Probably not repeatable. Probably not. Okay, because it's a few users they called and they're like surprised by this thing, right? Is it like predictable? Is it always going to happen at 10:30, after lunch? Probably not. This is a situation where I would go to somebody and I would say, hey, could you show me what happened? And they look at me like, no, I can't show you. It was a surprise. I wasn't expecting this. So that's another thing. So probably not not, I said repeatable, and like we just can't predict. It's in fact, let me just put random. Okay, random occurrence. And is it pervasive? Is it affecting like the entire instance? Well, in this situation, I just say a few users. So this is like very specific. It's very specific. A few users. It's like these are the small fish, okay, in a big ocean. Okay, small fish in a big ocean. In fact, I'm gonna put this a big ocean. Okay, all right. So these are very different, very different. And this is more session level also, where this is like the community. So for this one right here, this is perfect for an ASH analysis. Okay, so this one is just perfect. Okay, now this one right here is I actually solved this with ASH, and I'm going to save some time, and I'm not going to get into it. And the reason ASH worked though is because I needed to get down to the session level. I needed to see there was like things were going good. There was an explosion of activity for 40 minutes, and then it finished. And with ASH at the session level, I could see what sessions were causing that explosion. I could see when it happened, what they were doing before, after, all of that. With an AWR report, I just get this like summary of everything that was going on. And so that wouldn't have helped me nearly as well as doing an ASH analysis on this one. Okay, all right, but the first two are really the key ones for this presentation. All right. So the next slide is just some blah, blah, blah stuff for your reference. So I'm going to go right to the next one. All right. So what I want to do now is I want to focus on a time-based analysis. Okay. So I get asked this a lot because this is what I do. Okay. So it's like how to do in Oracle, it's time-based analysis. And I'm going to type in OTBA from now on. Okay. Because I can't type that. It's going to take me the entire hour if I keep typing that. Okay, so what is this? Okay, here's the situation. Okay. Users field performance like through time. Right? That's how they express it, right? When there's a performance issue, they say it's taking too long, right? It's taking too much time. Okay, so that's their perspective. So if our analysis is time-based, Oracle time-based, then we should be able to create like a quantitative link between their experience and like our analysis. And if we can like hook this together, then if we focus on reducing time, that should improve their experience. And it's like directly, if I reduce time, they feel the benefit. Now, is it perfect? No. Right? Is it really good? Yes. And we can get very, very specific solutions to the problem. Okay. So I'm actually going to dive into this. It's kind of the first half of what we're going to talk about. And then I'm going to demonstrate that using an actual AWR report. And since this is being recorded and you'll have the slides, and I'm going to type all this out, you'll have a good reference to kind of practice this. Okay. So that's why it works. Now, this is a little side thing, so I need to do this quickly because otherwise it won't make sense when I do this. So what we're going to focus on today is what I call the Oracle circle. That's where we're going to do the time-based analysis, okay? But I will always look at the operating system because if I understand what's going on at the OS, like what's the bottleneck? Is there a bottleneck? If I know that and I can see what's going on with Oracle, if I put those two together, it will lead me to the big SQL statements that are impacting Oracle and are impacting the operating system, okay? The SQL statements must be there. They have to be there because if they're not, then we would not be able to see the activity in Oracle or the operating system. So kind of the end game of the time-based analysis demo I'm going to do for you is I'm going to combine Oracle and extremely quickly, like a gross simplification of the OS, and that is going to lead us to the SQL statements. I like to call them the big fish because we're looking at the ocean of activity here, right, with an AWR report. And we need to drill into the big fish that are actually moving like the ocean, all right? All right, you guys still there with me? Give me some feedback here. I can't tell if anybody's still there. Okay, good. All right. So I like to check every once in a while because, I could be disconnected and I'm just talking to myself. Okay, very important for both a time-based and an ash-based is that we've got to believe that an active Oracle session is either consuming CPU or it's waiting on a non-idle wait event. Okay, and basically when a Oracle process cannot consume CPU, there's a reason for it, right? If it's trying to do some work, it needs to burn CPU. So if it can't burn CPU, there's got to be a really, really good reason for that. Like I'm waiting for some IO, a table is locked, whatever. And the wait event, right, that explains to us why, and it gives us clues as to why the Oracle sessions cannot burn CPU. So that's how I learn about a new wait event. I put it into a story and I say, the foreground process is unable to burn CPU because it is waiting for a lock for this table or whatever it is, kind of thing. And that helps me understand what the wait is all about and how it fits into the picture. All right, so we have a serial process right here. There's no parallel query going on here. So if you add up all the CPU, let's say time, units of time, whatever the units are, I don't care. So there's 11 units of CPU, and if you add up the wait, there's 9 units of wait time. Okay, this is important. That means the elapsed time, okay? That means the elapsed time. In fact, I'm going to put SQL. SQL elapsed time is going to be the CPU plus the wait time, okay? This is also going to be the database time. In a perfect world, this matches perfectly, okay? But it's not a perfect world, so it doesn't, okay? So that's the database time. This is not necessarily the wall time, okay? Because parallel query, plus there could be other stuff besides Oracle, and there's all sorts of other reasons, okay? This is the elapsed time. This is what we see in an AWR report, right? If I go down here to the SQL area, let me make this a little bigger. Here we go. See, it says SQL statistics right here. If I go down there, and let me just skip the elapsed time. Like, just look at the CPU. There's the elapsed time. This is what I'm talking about right here. Okay, that is the CPU in the wait time I'm talking about. That's what makes this up. That doesn't mean that's a user's experience. There could be parallel query going on, and that could cut that thing in half and by a quarter, whatever. Okay, all right, but we're not going to get into that right now. All right, just got to make sure we're clear on that. Now, with an AWR report, we're looking at the ocean of activity, and the ocean is full of fish. There's big fish, there's little fish, all that kind of stuff. And usually there is at least one huge, big, ugly looking fish that may taste good, but it doesn't look like it from the picture. Now, there can also be like a school of little fish that is super active and driving the current, okay? There can be that also, but I hope that it's always just one or two big fish, because the big fish, then that's my opportunity. And it's very clear where I focus my performance tuning efforts. All right, so remember, we're looking at the ocean of activity. We're looking for the big fish. All right, so how do we actually do this, okay? All right, we categorize the Oracle time, which is the database time. And the two main categories are CPU time, right, and wait time. Okay? And we're going to go through this based on an AWR report too. So let's focus on CPU time just for a second. There's two main consumers of CPU time in terms of processes. We have the Oracle foreground process, which is the DB CPU statistic, and there's also background process CPU consumption as well. Okay? So you add those two together, that's the Oracle CPU time. Now, we're not going to talk about queuing at the OS because that's going to take us where we don't want to go today. Okay. Now, on the wait time, what I do is I just have a couple high-level classifications of time, and then I break down IO into read and write. This just dramatically, massively simplifies what can be a very complex situation. And you're going to see that play out when I do the hands-on here. So essentially what I do is I just get like the 80% of the wait time, and I just grab those wait events, foreground and background wait events, and I slot them whether it's an IO read or write or it's something else. Okay, and people just get this. You can explain this to like a manager, and they get this breakdown of time, this classifications. Okay, all right. So that's kind of how we actually do that. All right. So let's see. Go to the next slide here. All right. So we're about ready for the demo. So and this is the actual example I'm going to use. So we're going to take this information, we're going to enter it into our classification scheme, right? So first we got to get the data. That's the AWR report. We got to develop our classification scheme, and we're going to, and that's what we're looking at right here. Okay, and then we're going to develop these big time reducing solutions, and I really do mean big time, because what we're going to do, we're going to see like piles of time down here, right? And those should attract our attention because they should be obvious. It's like, whoa, what is that? That's a lot of time. Well, if the users, right, if the user experience is based on time, and if we see a big pile of time, Oracle time, then that's where I'm going to go after that, because that is my biggest opportunity. Because if I can reduce that time, then the user is going to have a better experience, and then I get a major award, I get promoted, and then I get to go to a conference and hang out with all my friends. Good stuff, right? All right. So you guys ready for a demo? Do I hear a yes? I can't hear anything, so I'm assuming a yes. Okay, all right, here we go. So we're going to do our demo here, and this is the. All right. Oh, no problem. There's always a delay anyways, right? I mean, it's kind of the way it is. All right, so here's the demo. All right, so first what we're going to do is we're going to classify, we're going to develop our classification scheme. All right, so let me put this up here. Okay, let's get to the top here. And let's do this. All right. All right, now I want to do this really quick because I want to get into Ash, because Ash is really cool. So, but I always teach people AWR stuff first because you actually have to think through the problem. With Ash, you can be like an idiot and still get the right answer. I mean, it's kind of dangerous, right? You can get the right answer and somebody says, well, how'd you get this? You're like, well, I just ran the script. Well, what does it mean? I don't know. That's what can happen with Ash. But there's some huge advantages though. All right, so let's break this up. We got CPU, we got foreground, and then we have background. That's what that means, okay? Wait time, and we're gonna have our 2B classifications or IO and other, and for IO, we're gonna have reads and we're gonna have writes. So we're just gonna go through the wait events and put them in there, okay? Now, I noticed oh, by the way, this elapsed time, poorly named. That should be called the snapshot duration or interval. This is not the elapsed time we're talking about here, okay? It's such a bummer that that's what that is. So this is an odd snapshot interval. That's because whoever did this, they snapped it, something ran, and they snapped it again. So this is probably a manual snap here. All right, so we're gonna go right down. I'm gonna skip a bunch of stuff. All right, let's look at the CPU time. Okay, DB CPU is our foreground time. So I'm simply gonna copy and paste this right in here, okay? And we're gonna talk about the actual source too. Okay, all right. Now let's get the rest of the CPU time, the background process. The CPU time starting in 10G is in Oracle's time model. And Oracle puts that under wait events for some weird reason, but that's what they did, okay? So there it is. There's our time model statistics. There's the DB CPU. That's the source of the CPU time above. And you can see that 5966 matches right there. So that's the source of that. The background CPU time is usually right at the bottom here, okay? And that's our background process CPU time, and that's just about 1 second. And that's pretty typical, not much. So let's just add that up, and we get 5967 is the time there. Okay, I'm gonna get rid of the comma on that. All right, good. So now let's look at the wait time. Okay, now I do foreground and background, and so sometimes Oracle puts these together, sometimes they don't. Just be aware of that. Okay, so this says foreground. So the top wait event. Okay, now let me ask you guys, where does latch cache buffer chains go? Where does this time go? Does it go under IO or other? Type that in. Where do you think we should put that? Yes, no, it's not a yes, no, it's an IO or other. Okay, here's how I answer this. Okay. Oh yeah, okay. The way I do this is that it should be pretty obvious if it's IO, okay? And it's gonna be either I'm waiting for something to get back, like an IO to get back, or I'm waiting for a write to complete, something like that, all right? If that's the case, it's IO. This is gonna be other. And that's why I like other, because everything else goes into that, and usually if you add up or if you look at the contents of the other category, it's usually dominated by one, I'll just say, type of activity. In this case, it's clearly dominated by these cache buffer chains. Okay, and real briefly, we're not going to get into that. This is not like an architecture talk here, but what's happening is Oracle foreground processes are asking a question: is the block that I need to access already in the buffer cache? So it's a yes or no. Is it in the buffer cache? Yes. Okay, where is it? If the answer is no, the foreground process knows it needs to go do a physical read to bring the block into the buffer cache. Okay, so this is just a real simple question, but people are having, or not people, foreground processes are really struggling trying to get permission to even ask that question, right? And that permission means in order to get permission, they have to get the appropriate cache buffer chain latch, and they're unable to get that, so they're waiting, they're backing off. They're also spinning trying to get it, and that's reflected in the CPU time. Okay, now that's a whole nother talk, and maybe we can talk about that another time. All right. So the next await event. Okay, what category does cursor pin S go into? IO or other? Other, that's right. I put that in other. Okay, now I got even a more interesting question. Do we care about cursor pin S? Do we care about the 119 seconds? I mean, should we take the time and the effort to put that in our analysis? It's a good question, right? This is where people really get upset with each other. Yeah, people say no, people say yes. Here's how I answer this. I say, listen, if I was able to completely eliminate that 119 seconds with my amazing tuning prowess, right, would that change the ocean of activity, which is dominated by CPU and the cache buffer chains? Would that change that, like the current, would that change the ocean activity? No way. It's not going to, you won't even notice it's gone. Right? So don't spend your time focusing on these measly little pieces of time. You're going to get the major award when you reduce the 6,000 and the 55,000. That's the big pile of time where we're saying, wow, look at that time. That's related to the user experience. So that's where I'm going to focus. I mean, it's not rocket science here, right? This is actually very methodical and mechanical. All the brain stuff comes into what are the solutions to reduce that time. That's where the brain power comes in here, or whatever. I don't know what to call this. All right, let's add this up. Oh, we got to look for we got to check background. So we're going to go down here. We should have some background OS background wait events at the top. That's probably not very much time yet. 8 seconds. So forget that. We're not going to do that. All right, so we're good. All right, let's add this up. So we have 0 IO. Okay, I like this one because it's very straightforward. Put a 0 here, and so our total wait time is 52339 right here. Okay, so now what I do is I look for the big chunks of time, and I have 2 really big chunks of time, right? I mean that are pretty, pretty much the same. I have this is kind of like a 1A. This is like a 1B right here. Okay, that kind of thing. Whatever. And of course, the weight is dominated by the cache buffer chains right here. So that's my big one. Okay. So now what I do is I start thinking about solutions. Okay. Now remember, I'm focused on Oracle right now. Dang, I forgot to do that. I should never do that, right? It's 3 circles, right? This is just the first circle. The second circle is going to be the OS. Operating system. And then we're going to have application system, which is for right now is just the SQL. The users are not saying anything other than it hurts. All right, solutions. Okay, so I'm just gonna dive right into this, okay, because we're gonna run out of time here. I don't know of anything directly that I can mess with, that I can reduce the big chunk of CPU. So what I would do here, and by the way, this is where you think about like new features and say, okay, how can we reduce CPU, when our wait events cache buffer change, what can we do? Can I change spin count just for that latch? I mean, you just start going through these. This is where you get together. See, now that we've set up the framework, this is where we spend the time to come up with the solutions. And the solutions have to directly and obviously reduce time. Okay, if somebody comes to me with a solution, they say, hey, this vendor said we need to do this, or my buddy down the street said, he did this and it worked. And I say to them, okay, how was that solution going to change the timing profile in our favor? If it's not obvious how it's going to do that, just move on. Just move on. Don't focus on the solution. Don't waste your time. Okay. All right. So I do know though that with the cache buffer change, I'm going to abbreviate right here. Back. Let me put this. Okay. We need to do some additional analysis. Okay. And if you want to know what that is, check out my blog. Look at the presentations on cache buffer chain analysis. Okay, there are some very specific Oracle focused solutions, instance parameters, but we have to know some additional information that is not easily available in the AWR report. Okay, so and once we have that, then we can actually come up with a very specific Oracle solution for this. Okay, and that's just Oracle though. We're going to look at the OS and we're going to look at the application too as well. Okay, all right. So far, so good. Ready to move on to the OS? All right, let's do it. Okay, so we got CPU, I/O, network, and memory. Okay, and I'm not going to do all of these because we got to do ASH, right? All right, so I'm going to kind of cheat here, and I'm going to trust Oracle. Okay, so it's telling me from a CPU subsystem perspective, my busy time. I'm going to add these two together, the user and the system. So that's essentially 99% busy, okay? Busy, okay. My rule of thumb is I want that to be less than around 75 to like 80%. There's always a plus or minus there because it depends on like the number of cores and all sorts of stuff like that, okay? So clearly though, that's bad, okay? So that's bad, okay? Now, is it somebody's fault? Is it the OS guy's fault? Is it Oracle's fault? Is it the application fault? I don't care right now. I'm just looking for solutions, okay? So I'm just going to tell you right now, it's not a problem, okay? I/O is not a problem, and you're going to trust me with memory. If I look at memory right here, this particular instance is only consuming about 6% of memory, and hold on, 6% of memory, but check for other instances. Okay, so we're gonna need to go to the OS. Okay, all right, and on the network, I'm just gonna assume it's not a problem right here. Okay, if I even have a hunch that it's a network, and I'm not gonna get into how I do that, I will always get the network people involved. Okay, because that is outside of my domain, really. Okay. All right, so right now, from an OS perspective, I got a CPU bottleneck, okay? All right, so what some solutions would be from an operating system perspective, more and or faster CPUs, okay? Now, is that the deepest, truest, long-lasting solution? Probably not. But if I can get some really quick, it would really be nice though. All right, and that may get me through, while I'm doing some additional analysis right here to actually figure out what the greater or I'll say the longer lasting solutions are. Okay, all right. Now this is kind of the end game here for this right here. Now, if you look at the SQL's statistics, see right here in the report. I'm going to click on this. Oracle, the AWR report does a pretty good job of ordering SQL by a number of different categories. And so what I do, and I'll just put a couple of these, like physical I/O, reads. I'm going to do like parsing, sorting. Sorting is not listed here, which is a bummer because sometimes we're looking for SQL that's doing a lot of sorting. What else are you going to put? I'll put elapsed time. I don't want to get into elapsed time today though, because I have to talk about parallelization and all that. Okay, so this is the end game here. Okay, I want you to see the entire profile right here. Hopefully that is big. Let me make this a little bigger here. All right, here we go. Okay, so looking at our Oracle time-based analysis, the timing profile, and looking at the operating system, what the bottleneck is, if there is a CPU bottleneck. If I put these two together, I ask myself, will there be big fish in the ocean that are consuming a lot of CPU? Okay, so what do you guys think? That's like a yes or no maybe. Is there big fish that are consuming, or big fish or a bunch of little fish that are consuming CPU? In other words, can we see the impact of that at the OS level and at the Oracle level? What do you think? Yeah. Okay, we got some yes? Yes, there has to be. Yeah, right. Exactly, you guys. You see, it just makes sense, right? This is not a trick, right? It's not a trick. If if there's a CPU bottleneck, there must be something consuming CPU. And this is an Oracle system, right? And we see here too that we're consuming a lot of CPU right here. Okay. And really this wait time, this is once we get the latch, we're going to burn CPU. So this is all about CPU. So there must be CPU consuming SQL statements. There's gotta be. All right. Physical IO. If you look at the operating system and our time-based analysis, is there physical read SQL statements that are big fish? Yes or no? Now, I will say this while you're thinking about this. Okay, the top physical IO SQL could also be the big CPU consuming SQL statements. But that's not the question, though. The question is there a lot of physical IO? Are there big physical IO SQL that's driving the OS situation and the Oracle situation? Okay. Clearly, the answer is no, because we have zero time right here. Okay. And I said IO is not a problem. Okay. You just kind of have to trust me on that one. All right. So the answer is no. Okay. So if we go through these, right, each of these, I do the same kind of thing. I say, do I see what's happening at Oracle and the OS? Do I see that there must be SQL statements of a certain type or kind that are driving this? Okay. And so I'm just going to stop. I don't want to get into elapsed time because that's a whole other thing. So there has to be CPU SQL. See, and people ask me all the time, they say, well, what if I don't see it? You've got to see it. The only exception really is if you're not using bind variables and we have a lot of little fish. And that's a stinking nightmare and that's a bummer. Okay, but that's a whole nother thing. Ash, you can use to help find that situation. All right. Okay, so I'm going to click on CPU here, which is right below the elapsed time. And these are my SQL statements right here. And they're weirdly similar. Okay, so all I do is people say, well, Craig, what's the SQL? I say, okay, these are the SQL you need to focus on. These are the big fish. I say, well, how do you know that these are important? It's because you're having a bad experience, Mr. User, and that's because it's taking too long. And I have found the SQL statement that's consuming a lot of time. And these are probably the statements that you're having a bad experience with, especially because you've told me that this is a system-wide pervasive situation. It's not just about one particular business function or one SQL statement. So these are the big fish. So let's go reduce the time on that. It's going to reduce the load on the OS. It's going to radically change our profile right here. Okay. All right. Whew. All right. So that's our time-based analysis. We have solutions. We have Oracle solutions, or paths to go down. We have an operating system solution. We need some CPU here. And we have some application-focused solutions. We have some SQL statements that we need to reduce specifically the CPU time, if at all possible. Okay, or reduce the number of executions, right? But it's kind of tough to reduce executions when they're running once. Okay, all right. By the way, this is an interesting one here, but we're not going to get into that because that's kind of, in fact, how many are those? Yeah, a bunch of those. Okay. Anyways, all right. You guys okay? Ready to move on to Ash? Because Ash is so very cool, and I have till top of the hour, right? All right. So what, can I go like 10 minutes over? Is that going to be okay? No. Oh, really? Okay. All right. Well, I'm just going to relax then. All right. As long as you guys want to stay. All right. I know, but you guys have jobs, all right? I know you have jobs. Hey, I'm going to respect your time. Plus, I got other stuff to do today too. Tomorrow I go on vacation. Gotta get ready. All right, so that's a time-based analysis. Okay, remember, if it's pervasive, repeatable, that is when AWR analysis really rocks. Okay, I find 80% of the problems I deal with, just once I understand a little bit about it, I look for these characteristics. I say, hey, just send me an AWR report for an hour during the really bad time. And I go through this analysis, and as you can see, it's pretty mechanical. Now, if you're not used to doing this, especially the Oracle time-based analysis, it's going to feel really awkward. It's going to be like, this just seems really strange, right? In fact, it's almost kind of demeaning because we think, oh, Oracle DBAs were like super smart. You know, we want all this really detailed analysis. And it's like Craig, you're saying, we don't need to do that here. We just need to add up the time and look for the big piles of time. Exactly. So it's almost kind of like, I want it to be more complicated than it is. The complication comes when you do things like this, the additional analysis for cache buffer chains. See, that's where you want to spend the time. You don't want to spend the time understanding the ocean of activity. Okay. All right, so let's move on to Ash, because Ash is so cool. Yeah. Oh, that's the easy answer. It's because I made a typo. There we go. How's that? Yes, that's good. No, it's this extra, it's the Phantom 10. No, that's it. Very good. That means you guys are actually listening. Man, I love that. All right, let's make sure we can get on the screen. How to do an Ash focused analysis. Now, before we get into that, we got to understand what is Ash. Okay, this is like the, oh yeah, yep. Yeah, yeah. Mm-hmm. Oh, how do I check that? I'm gonna if I have any questions about that, and I'm not really sure if the CPU subsystem is really struggling, then I just go to the OS admin. You know, I'm not going to guess. If I think that could be wrong, which it very well could be, okay, but that's a whole nother discussion, okay. And I always do the math. I never actually use the results from the AWR report because in the further on down in the report. Let me go back up to the top here. What I do is I go look at well, it's going to be right up here. Let's get the operating system stats. I'm going to look at this. I'm actually going to use some of these to derive the CPU utilization. Okay. And if I have any doubts that there's an issue with that, then I will definitely talk to the OS guys. Right. And by the way, you should be able to run like a VM-stat, SAR, and top. That's just part of being an Oracle DBA. Okay. Yeah, I mean, that's part of that, I mean, that's why I spent about 2 minutes talking about the operating system, right? Because that's a whole nother discussion. And by the way, I got webinars and blogs and all sorts of stuff on that too. So, all right. Yeah. If you got questions about that, talk to like the expert. Okay. Yeah, the whole thread, hyper-threading, all that kind of stuff. It's just, cores is what makes the difference. Okay, don't let anybody. Ultimately, every thread, I don't care if it's hyper, plutonium, or what it is, it's got to reach a core. All right, enough said. All right, moving on. Let's talk about Ash. All right, here's the best way I can explain Ash. Let's say that I wanted to know for some reason, all right, what you do at work. All right, so you and I have this discussion, and we first say, hey, why don't you just fill out a time card? All right, so every time you're done with like a little part of a task, you write that down, and then you give that to me. And then what's going to happen is I'm going to have like all this paper, and I'm going to have to manage that. And you're going to come back to me, you're going to say, man, this is a hassle, Craig. It takes me time to actually fill this out. I said, is there another way besides me filling out a time card Because, I mean, do you really need to know actually when I start and exactly when I stop and the exact duration? I say, no, I really don't need to do that. And really, I don't want to have to deal with the management of all the paper and all that. And so we say, let's come up with a different strategy. Okay. Now, this first strategy, the time card, that's like Oracle time. That's what we would analyze that just like we did with this time-based analysis. Okay, that's where Oracle is recording how long things take. All right, that's how we're able to do a time-based analysis. But we say, no, we want to come up with a different solution. So what we do, I come up with this really great solution. I say, hey, I'm going to put a camera behind you, like right behind me right here, right? And I'm going to take a picture of you. And I'm going to have a stack of pictures. And then based on those pictures, I can like create like a flip book. This is kind of this next picture here. Remember those flip book, that kind of thing? I can create that. I can, with all the pictures that I take of you, I can flip through those and I can kind of see what you're doing throughout the day. Okay. In fact, really, the truth here is that I not only need to take a picture of you, but I need to take a picture of everybody in the office. So I'm going to have this huge stack of pictures every time I take like your picture. So basically, if I look at the entire office here, I'm going to go like, and I'm going to have all the big stack of pictures. And I'm going to wait for a while, and I'm going to take another set of pictures. I'm going to have another stack, and then another stack, and another stack. And based on all these stacks of pictures, I can answer some really interesting questions about what you guys are doing in the office. Okay. Now, once we say that sounds like a good idea, the question is, well, how often should I take those pictures? And we say, hey, let's just do it like once a day, just one picture a day of the entire office. Okay. And so, but there's a problem with that because you say, well, Craig, what if I'm just stepped away from my desk when you took the picture? I'll say, yeah, that's a problem because if somebody asks me, what did you do today? I'm going to look at the pictures. I'm going to say, hey, I have no picture that you were even at your desk. So for all I know, you didn't even show up to work today. And so you're thinking, yeah, that's not that's not good. And so he said, we need to take pictures more often, right? More frequently. So we talk about this and I say, hey, why don't I take a picture like every second? I'm gonna have this camera behind you just going like click, click. In fact, I'm going to take pictures of everybody every second. And you look at me and you say, man, that's really creepy, Craig. Right? That's super creepy. I don't want you taking that many pictures of me. I can't even rub my nose without you getting a picture of that. I'm like, yeah, that's probably, that's too frequently. So we have this back and forth discussion. And then we determine, say, okay, let's do like every 15 minutes, we'll take a picture. Okay, now I could still miss some stuff. Like if you step up or if you're doing something and I don't have a picture of it, I can't prove that you were actually doing that. But that may be good enough to answer the kind of questions that I need to ask. So let's talk about like some of the questions that we can answer and some of the questions we can't answer. Okay. And by the way, Ash is just like this camera, right? There's a background process that takes a picture of all the Oracle active sessions once every second. So basically every second we get a big stack of pictures. One picture, right, for each active Oracle session. And on that picture is all sorts of details about what is in that picture, right? It's not only like the picture, right? It actually has a list of like, okay, well, they were on CPU. What SQL statement we were running? What's the module? What's the action? What's the plan hash value? All this stuff. Every single picture is just loaded full of information. By the way, when I take those pictures of you, you don't have to do anything. You just do your work. So the burden of you filling out a time card is gone. And you might say, well, yeah, but then you don't know exactly how long it takes me to do stuff. And I say, I really don't want to know exactly how long. If I have enough pictures, I'm going to be able to answer the questions I need to answer. And you might say, well, what kind of pictures? Okay, these are the kind of pictures, okay? I can actually say, let's say, I could answer the question, what's the most CPU intensive SQL statement within the time entry module between 8:12 and 8:24 today? Very specific, very specific. Crazy time, like 8:12 to 8:24. Like, what is that, I can answer those kind of questions with ASH. There is no way, it's impossible to answer these kind of questions with an AWR report. So if you need, right, those real specific session level, detailed time, if you need those incidents, if you need details like that, you've got to use ASH for this, okay? All right, just real quick about ASH, is designed like an airplane's like black box, so it's going to keep collecting until the instance stops, okay? And you could lose some information if it's only stored in Oracle's cache. And the background process that takes the picture once every second, it stores that information in the shared pool in a ring structure, and it wraps around. That ring will fill and then overwrite the other stuff. And before it overwrites the older ASH data, right, it will that data gets copied into the AWR ASH table, okay? But we don't have every sample. Only 10% of the actual pictures get copied into the AWR tables, okay? Right. I don't want to get into any more detail about that, all right, because we're going to go on a long ways. It's going to take us too long. All right, because I actually want to start typing here really quick. All right, let's say these are the pictures that I have of you, right? In this case, I took a picture every 10 minutes, and I can tell if you were at your desk, what was on your computer screen. Was your left hand on the keyboard, yes or no? And was there a cup on your desk? Now, why do I want to know that? I don't know. Maybe I have to answer some management question. Maybe that they feel this is important. But that's what I store. And I also need to know what color your shirt is. Interesting questions, I know. So let's look at some of the questions we could ask. First of all, I can answer questions related to super crazy times. I can summarize this. All right, I could say 75% of the pictures of the samples, you were at your desk, and then you were someplace else, I don't know where, but you were not at your desk 25% of the time. And I can answer all sorts of other questions too, okay? But I really want to get to the more interesting questions, okay? Here's the question, and we're going to do this the first three here, okay? Question, were you at your desk at 8:47? Okay, here's the data. Were you at your desk at 8:47? That's where. I always do that. Were you at your desk at 8:47? All right, what's the answer? What do you guys think? Can't tell. Not sure. I can infer that you answer. I can infer that you were, but can't. Yeah. See, okay, this is an important question, because to do ASH analysis, you must be aware of of the reality of the data that we're looking at. Okay, I cannot prove that you were at your desk at 8:47, because if I inferred, I said, well, you're probably there. You could say, prove it. And I could say, well, you were at your desk at 8:45 and 8:55, and you could say, that's not proof, Craig. You're making an inference. Do you have any pictures? I'll say, no, I don't have a picture. So I can't prove it, but I can make an inference. So we have to be careful when we use ASH data. Are we proving this, or are we making an inference? It could be a strong inference, right? But be aware, though, that we're not going to have perfect information. So just don't get yourself don't trap yourself, is what I'm trying to get at. All right, here's a good one. Did you ever watch Fox Sports between 8:30 and 9:15? Here we go. Let's look at our data. Did you ever watch Fox Sports between 8:30 and 9:15? What do you think? What's the answer to that? That's a highly paid manager question. Hey, did you ever watch Fox Sports between 8:30 and 9:15? Yeah. It's not most likely. The answer is yes. And I have pictures to prove it. So if you try and put me in a corner and say, well, you can't prove that, I'll say, oh yeah, well, look at this. And you're like looking at Fox Sports, like, uh-oh, gotcha. All right. So Ash sometimes can prove it with an actual like sample, an actual picture. Pretty cool. All right. All right. So we'll look at one more, and then I think I've made my point here. Oh, this is the best one. Did you change your shirt on December 13th? This is the day, right? Between 8 and 10. Did you change your shirt? All right, so let's actually look at our data again. Did you change your shirt between 8 and 10? Yeah, you look at it, you say, well, hey, wait a second. It was blue at 8:55 and it was red at 9:05. Now, I don't know why you changed your shirt, and I don't want to know, but you definitely changed your shirt, and I have pictures to prove it. Okay. Now, I just did at the Utah Oracle user group last week. Somebody had a really good answer to this one, but I want to type this in here. Yes, and I have a picture, and I have a picture, pictures. Okay, so so he said, well, Craig, maybe that was somebody else that stepped into the office. Ooh. And I'll say, hey, my pictures, I have this special software so I can tell that it was actually you. Like, okay, all right. But I thought that was an interesting answer. Okay, so now that we know about Ash, let's actually, do a demo here. So, but clearly, sampling it's powerful, but it's not perfect. It's not complete. Okay, but do we need perfection? If you do, don't use Ash. That's the answer to that one. Okay, if you need perfection, well, you're not going to get perfection because perfection, there's too much overhead in perfection. Okay, and you're not going to need that anyways, probably. Hopefully not. Okay, questions that we typically ask. All right, I'm glad we can go late because I can tell I slowed down a little bit here. Typically, we're going to summarize your profile something. We're going to find the top something like top SQL, top module, top session. And with Ash, we can timeline. We can do that flipbook. We can actually watch a session, watch what they're doing. And then we have a lot of data. We're going to group all the active sessions and we're going to just summarize them in one line. So we're going to have like, this is like 1 hour of summarization, another hour of summarization, another hour of summarization, right? And we can get a really good idea of what's going on. And we can use that to spot or to locate, right, when the bad stuff is happening. Because usually with Ash, there's an incident that's we're having an issue with. It's like the needle in the haystack. AWR report gives us the haystack. Ash, we can identify the needle, the incident. Okay. Now, sometimes the situation is really complex, and a nice linear kind of, nice linear diagram is really not that helpful. So I actually have, I have a toolkit called my Bloodhound Toolkit, where we can actually take Ash data, extract it, and put it into the free statistics package called R, and it will create a chart, a graph, a network diagram of the situation. It's pretty cool. And if I get a chance to do a webinar just on Ash, I'll actually demonstrate that for you. Okay. All right. So let's do the demo for Ash. Okay. So I hear something. Is that just you? Who's you? All right. Okay. All right. Okay. So I'm connected into Oracle right here. We're going to get into SQL Plus. Now, what I'm going to use here, I'm going to use I call this my Ash scratchpad. Okay, anybody can download this thing. So actually, let me go to here, and if you go to my website, just go to OraPub, and I love that other picture. Resources, tools, right here. Okay, and the scratchpad Bloodhound toolkit is my advanced Ash analysis toolkit. This is what I'm going to look at right here. Okay, anybody can download that thing, and it's actually a complete text file right here is what this thing is. I use this a lot, and it's really good to demonstrate and to learn about Ash. Okay, all right. So I'm gonna go through this super fast. Okay, and you're gonna see we're gonna answer some key, very typical Ash kind of questions like when did the thing begin, who started it, how long did it last? Just kind of like who done it mystery type questions. Okay. Now, to use the scratchpad, we need to identify the source of the data that we're looking at. So the first thing is the actual data source. And you can see I have a couple of very typical options here. In fact, let me make this bigger. There we go. Let me do it like this. So it's typically $$ active session history, or it's the DBA hist active session history. What I did is I created like an extract, a copy. I basically, I actually did like a create table. Well, I'll tell you the name of the table. The name of the table is right here. I did like a create table, this as select star from $$ active session history. Okay. And I have down here, I got a little script, extracting your chosen data. I just updated this document. I put this in yesterday, and the new one is online, but this is how you can extract the data so you can save it for an analysis later, like what I'm doing right now. All right. Now, this is a $$ looking table. It's not DBA hist, okay? So there is no DBA hist details, but every single one of my SQL statements that I'm going to use has this defined in it, so I just need it to be true. Okay, now this will be clearer in a second. Okay, all right. In fact, yeah. All right. So now I get the timing details. Okay. Now here's the situation, though. I forgot to tell you this. This is important. Okay. Here we go. Here's the situation. This is what the users told me. They said, "Hey, Craig. Hey, myself and a couple of colleagues, we returned from an early lunch today," which happened to be yesterday. Okay. When doing some work, our screens froze for perhaps a minute. It's never happened before, and it hasn't happened since. We just thought you would like to know because it surprised us and we couldn't do any work. Okay. Classic Ash situation. There's a few users. It happened at a specific time. Oh yeah, when they got back from lunch. And it was like random. If I asked them, "Hey, can you show me that?" They're like, "No, I can't show you that. It's random," right? That kind of thing. All right. Okay. So this is the situation. So what are the clues? I'm just going to copy and paste this right in here. What are the clues? Answers: few users. They told us the time, and their screen froze. Time specific. Okay. Very, very specific. So what I'm going to do here now, back to this. We're not using DBA hist, but this will be included in these SQL statements. Here, I want to see myself. That way I know I'm still around here. So I'm gonna paste that in SQL plus that define. Oops, I already did that. Okay, now I got to do the timing details. Okay, now we know it was after lunch, and I didn't really tell you this, but this is actually. Well, let me just copy and paste this in here. Okay, so I'm going to do this. It was yesterday from 11 in the morning, yesterday till about 2 p.m., 1400 hours. Okay, and I don't do seconds here. I just do up to the minute. Okay, all right. So now I can constrain what I'm looking at. I'm looking at the actual table that has the Ash data. I know that I'm not going to use DBA hist data. If I was, I would need the database ID and the instance number. And I also need some timing information. When did this thing happen? Now, I don't know exactly when it happened because they didn't tell me. They just said, well, it was like right around lunchtime. We took an early lunch. Okay. Now, if I had an alert log or some other log that told me when the bad thing happened, that is really helpful in a situation like this. All right. So the first thing I'm going to do here is, okay. I'm going to do what's called, I call this a tick report. This is that interval summary. Okay, so I've set these defines, and we're gonna create some summary, like a summary report. Now I want to make sure I'm actually looking at some real data. So I'm going to run this little query right here. Okay, so this query right here, you'll notice I just get the minimum sample time and the maximum sample time and a count. So I want to make sure I'm actually have some Ash rows, some Ash data that I'm looking at. And so this is why I need to set the source. I need to set the timing details, right, which is this right here. And I need to, I always include the DBA hist define as well. Okay, and so I can see that I'm actually, when I run all of my reports, there is available to me to process 33,416 Ash rows. That's a lot of pictures, right? I got over 33,000 individual pictures, right? Over about, well, this is like a 2 hour, no, over a 3 hour time span. Okay. All right. So let's see, common formats. This is kind of nice, right? All right. So we're going to start with, we need to, we're looking, this is an incident. I need to know when it happened so I can focus on, well, so I don't have to look at all the data. There are thousands, right? There are thousands and thousands of rows in ASH data. We don't want to spend, I can't scroll back looking at thousands and thousands of rows. So I need to converge on what I'm looking for. Now, what am I looking for? Well, a screen froze. So I'm going to think, okay, what wait events are related to a screen freezing? Okay, all right. So what I'm going to do is I'm going to do this down here at the bottom. I call this a tick report here. And we're going to look at this situation in 600-second grouping. So each line is going to summarize these rows right here, right? I'm going to summarize this in 600 seconds, which is what, 5? Is that 10? No, 10 minutes, 10 minutes, okay? So I'm just going to copy and paste this. This is the most complex report. All the rest are like really simple. Okay, here we go. All right, so I have the SQL in there. I'm going to run this, boom, and of course that wrapped. There we got it. Okay, so you can see, look at the jump here. Okay, oh that's because of the timing when it started. But these are 10-minute jumps. You see 12:30, 12:40, 12:50, 1 o'clock. Okay, this is the total active sessions. Now, these are all the pictures within this time interval right here, okay? And this is the average active session. And out of all these active sessions, this is the percentage that were on CPU and the percentage that were waiting. And then this is like just the top wait event. There could be another one like right next to it, but this happened to be the top one, okay? Now, I'm looking at this, I'm thinking, is this what I'm looking for? Okay, now it could be in this situation, but I'm thinking that their screen froze. And it only happened once, and this can actually cause a screen to freeze on a commit, but it would have happened a lot. And this wasn't like this. This was kind of a random one-off kind of thing. So I'm thinking, I can't see what I'm looking for. And so what I'm going to do is I'm going to drill in. Instead of summarizing at 600 seconds, I'm going to summarize at 60. Now I'm going to get more rows back, so I have to balance this. If I get too many rows, I got to scroll back, and it's really irritating. And it's a hassle. But I'm going to just change this, the groupings. I'm going to paste that in, and I'm going to run the exact same SQL script, and boom, now I have more detail. Now I'm looking for something around what, just before lunch, kind of the thing they said. Okay, here's a row lock. Okay, that was at 12. What did they say when they got back from lunch? What did they say? When returned from an early lunch. Okay, that could be returning from an early lunch. That, in other words, see, this makes sense. The story that they're telling me and their experience, this looks like what could be the issue. And it's kind of a random thing, right? This doesn't happen all the time. Okay, so I think I've got the time, but what I need to know is when did it begin and when did it end? So let's take a look at that. So I'm going to drill in even further. I'm going to drill in at the 10-second level. I'm taking a little longer here. Okay, I need to speed this up because we want to drill into this stuff later if I get the chance to do this again. So there's some activity. Okay, here we go. Here's a couple of them right here, right around that time. Okay, so we know this is right around 12:49. Okay, so that's a common question. When did it begin? When did it end? Well, it looks like it began right around 12:49, and it actually finished later on at 12:49. And in fact, it could have gone even further than that. I'm gonna drill in even more because I'm summarizing at the 10-second, and I'm only showing the top wait event. So let's go. So you see now that I have more detail, things are looking a lot more interesting. So we want to get to this 1250 here, right? Right around there back. See, this is a hassle, a lot of rows. Just imagine if this was like a big production box. Man, come on. Woo! 12, was it 1250 something? There's my lock. I'm going to start seeing some locks around here. was it? Oh, I forgot the time. I think it's right around here. There we go. There, you see, there they are. There they are. Yeah, right there. Right there. Okay. So it looks like one of the first occurrences is right around this 40, just about 1249, and we can see it's happening quite a bit here. Okay. And at that particular time, it's really dominating a lot of the wait time. Okay. All right. And then it ends right around here. Okay. I actually have another one right here. So this is like the last where it really dominated. Okay. Right there. So right around that 1249. Okay. So I can get an idea about how many sessions were involved on the system at that time and all that. Okay, so now I kind of know when it began, when it ended, how many sessions were involved, and it matches the user experience. And I can also, because I'm not using just a drill down tool, I can actually modify this. I can add additional columns. I can do all sorts of really cool stuff. I have a lot of flexibility here, okay? All right, now what I'm gonna do is I'm gonna I don't wanna look at this much data. So what I'm going to do is I'm going to constrain the time. I'm going to make it tighter, okay? So I'm going to reset the timing details, and I'm going to start at 1248, and we're going to end at 1250. So I'm just looking at 2 minutes of data out of all that ASH data, okay? And any report I run now, like the same report, now I'm just going to get a couple minutes, okay? And you can see it's not nearly as long now. That's it right there. But I should have within that the row level locks, or the TX locks right there. Okay, all right, that's gonna be helpful to me. Okay, now let's find the top session. So let's go to the top report. I'm gonna do this really quick. We're not gonna, because I want to cut this short here now. So top anything. What I want to do is I need to set the columns I want to display, and I can also say, well, I only want to report on if we're on sessions that are on CPU waiting, or I don't care. Okay, so in this case, what I want to do, I only want to show sessions that are waiting. Okay, and let's see, I want to show the event and the SQL ID. Okay, and then look how simple the SQL statement is. I wanted you guys to see that these scripts can be they can be incredibly simple right here. Basically, I'm going to get a count right here of the columns I'm looking for, which is the event and the SQL ID, okay? And this is going to be from my source, then there's the timing details, and where the session state is, well, it's like waiting, we're waiting, okay? So I go here at the top and I say, okay, now, what's the top SQL related to this wait event right here? You can't get this with AWR data. It's just not going to happen, man. It's not going to happen, okay? So that is my top SQL. Okay, and to do that, in fact, I'll put this in here for you guys right here. Okay, in fact, here we go. That way you have a record of this. It's right here. It's on the recording this way. Okay. Oh, that's the top. Let's see, top SQL, top session. All right. Well, right here we're showing the top SQL. Let's go for the top. Let's see. Oh, how about the top? This is a common one too. What if I want to get the top module? I want to show the event in the module. Same SQL. Same SQL. And we're looking for just the wait events. That's it right there. There's my top module right there. It says update ASH test. Gosh, what a surprise, right? That's it. That's my top module. And to get that, what I set was, that's what I set in my little toolkit. That's all I needed to do. And I can do the same thing for the top session. Now we need to do that because we want to timeline one of these sessions. And that's going to be the last thing we're going to do then. So what we want to show is the event. I want to know the session ID, and I also need to show the session serial number to see if that's changing. You got to be careful about that. Okay, I'm going to run the same SQL, and now let's go to the top here, and this could be long. There we go. We're looking for. There we go. There's my row level locks right there, and you can see I got a few sessions right here. Those are like my top sessions. So now I know the sessions, I know the SQL, all that kind of stuff. So I'm going to grab these three. I'm going to put that in the notes here. See how easy this is wrapping. It'll be okay. This is like the beauty of ASH, and it's like it allows you to kind of discover and explore what's going on, which I just love that about this. It kind of gives me a lot of freedom. I don't feel constrained. So what we want to do now is we actually, we're going to like timeline this session right here. That's the session number, session ID, and that's the serial number. Okay, so to do that, in fact, gosh, there's a lot more I could do. I'm going to save this for another time though. But we are going to timeline. We're going to timeline just this session. Okay, and since it's a locking situation, there's the blocking session, and we could timeline the blocking session, which can timeline its blocking session. We can just follow the whole chain. We can do that, but we're not going to have time to do that right here. So what I want to do here, we're going to timeline one session. Okay, we're going to make this pretty straightforward. So we're going to go after session 409, and the serial number is the 62964. Okay, and so we're just going to look at this one session right here. See, I could actually show all the sessions that are waiting for the lock. I could do that, or I could look at all of the sessions. I could timeline, which is kind of crazy, but I could do that. Okay, so that's my where clause. Okay. Oh, what do I want to show? How about I show the event, the SQL ID, and the blocking session? Okay, and I'm going to assume it's going to be session 409 right here. All right, so that's the entire SQL statement. So the other reason I like the scratchpad is it allows me to, it's all text, so I can change this, I can modify, copy, and paste it, right? Most people have something like this that do Ash or scratchpad. So this is this session right here. We can see when it started, right? See I mean, if it had connected earlier, we would have seen it if it was active. Okay, but now it's actually doing something. It's trying to do something, but it can't because it's waiting. It's waiting on a row level lock, and that's the SQL. So we can learn a lot from this right here. It's running the same SQL ID. It's blocked by different sessions. Okay, and we know when it was, and we know this is Ash data. You see it's jumping, it's very active. Every second, boom, this guy is active. So he was trying to get a lock here from here all the way down to here. And then it looks like he finally got it because he was able to burn some CPU. But then he had to wait on a log file switch. It was a bad day for this guy. All right. Anyways, so that's what you can do. You can actually timeline this. All right. So that's the last thing I want to show you. What we could do then, we could say, well then what's 403 doing? And we can follow the chain. And you discover all sorts of stuff. So, we've actually learned, quite a bit from this. All right. We know when it started and stopped. We know how many sessions were involved. We know the SQL ID. We can actually follow the chain to find out what the core problem is, which we haven't done because we're just out of time. We'll do that another time. Okay. So, but what I wanted you to see is that we can get down to some very, very specifics with Ash data. We can do things that we cannot do with an AWR report. Okay. Now, an AWR report is very fast, and everybody knows how to run an AWR report. So that's why I use AWR reports a lot. And plus, the solutions, the path to the solutions just make a lot of sense for most people. For Ash, it's a lot more, we're jumping around, and so it's harder to explain the analysis to people. That's one reason why I like AWR reports. But I can't answer very specific questions like we're seeing here. Okay, and I haven't even answered all the questions that we could answer because we're just out of time right here. Okay, all right, I think that is it. All I have now is just, if you want to learn more, go to my blog. Okay, do a search for these keywords. You could go to my website. Again, do search for the keywords. And of course, I do a lot of teaching and all sorts of stuff and all that. And I do have some public webinars also. Like this webinar will be posted on there as well. So, okay, that's it, guys. Man, that took way longer. Yeah, thanks for letting me go a little bit long there. If you guys have any questions, I'll be happy to take the questions. Yeah, good. Cool.